Next, we will see properties of a convergent series. Let the sum of an and the sum of bn be a convergent series. Convergent series be two convergent series. Then one. The sum of c times an is equal to c times the sum of an, where c is constant. Where c is constant. Where c is constant. Where c is constant. Then the sum of c times, as you can see, n is equal to c times the sum of the an. This implies that if an is convergent series, then constant multiple of that series is convergent. The sum of an plus bn is equal to the sum of an plus the sum of bn. The sum of an plus bn. The same will be true for minus. So this one is a property of the convergent series. Let me give you one example for this. Find the value of the series. The sum n starts from 1 to infinity, 3 over n into n plus 1 plus 1 over to the power of n. Let us see the value of this series. Using the property B, we can rewrite this sequence as the sum n from 1 to infinity of the series 3 over n into n plus 1 plus 1 over to the power of n can be written as the sum n from 1 to infinity 3 over n into n plus 1 plus the sum n from 1 to infinity 1 over to the power of n. This can be written using the property this one. Then using the first property of the series, this can be written as 3 times the sum of 1 over n into n plus 1 when from 1 to infinity plus the sum n from 1 to infinity 1 over to the power of n. Using or applying the first property on the series. As we have already seen, the series 1 over n into n plus 1 converges to 1. Converges to 1. So this is equal to 3 times 1 plus, as we have also seen so far, the sum of 1 over to the power of n when n start from 1 to infinity is 1. So this is equal to 3 plus 1, that is equal to 4. So this property of the series enables us to determine the value of the series. There are also an important theorems. If the series an is convergent, and the series bn is divergent, then what do you say about the series, the sum of an plus bn? It is divergent, divergent. So the sum of convergent and the divergent series is divergent. The other one is, if the series an and bn are divergent, then the sum of an plus bn is may or may may not divergent. So if the divergence of two different series does not imply the divergence of their sum. For example, you can take the sum of say minus n, the sum of n from 1 to infinity, and the sum of minus n from 1 to infinity are divergent. But the sum of n plus minus n from 1 to infinity is convergent. So the divergence of two different series does not imply the divergence of their sum. There is also the theorems that called a term test. If the series the sum of an is convergent, then the limit of an as n goes to infinity is equal to 0. The limit of an as n goes to infinity equal to 0. That means if this series is convergent, then its sequence must converge to 0, but the converge is not true in general, but the converse is not true in general. For example, limit of 1 over n as n goes to infinity is equal to 0, but the sum of 1 over n when n starts from 1 to infinity is divergent. This one is divergent, but the limit is 0. So the converse of this theorem is false. If the limit of an as n goes to infinity is different from 0, then we can say that the sum of n from 1 to infinity is divergent. That called term test. This one is one way by which we can determine the convergence of the series. If the limit of n as n goes to infinity is different from 0, then we can say that the series, the infinite series an is divergent. As an example, take this sum, the sum of say 5n plus 2 over say 4n minus 7 when n starts from 1 to infinity is divergent, since the limit of 5n plus 2 over 4 times n minus 7 as n goes to infinity is equal to 5 over 4. That is different from 0. So those are some property of the series. Next, let us see some types of the series. Harmonic series. Harmonic series is a series sum of 1 over n when n starts from 1 to infinity is a series. This series is called harmonic series. It is divergent series. Harmonic series is divergent series. We can prove that. Let us prove. proof. For the sum of 1 over n, when n starts from 1 to infinity, S1 is equal to 1 over 1 is equal to 1 is equal to 1. S2 is equal to 1 plus 1 over 2. 1 plus 1 over 2. That is S to the power of 1 now. This is equal to S to the power of 0. S to the power of 0. S3 is equal to 1 plus 1 over 2 plus 1 over, say S4. S4 is equal to, let us see some of the sequences. We are observing some of the partial series. S4 is equal to 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 4. This is greater than 1 plus 1 over 2 plus 1 over 4 plus 1 over 4, isn't it? Since 1 over 3 is greater than 1 over 4, greater than 1 over 4, which is equal to 1 plus 1 over 2 plus this 1 over 2. That's equal to 1 plus 2 over 2, 1 plus 2 over 2, 1 plus 2 over 2, 1 plus 2 over 2. Let us see S to the power of 3, that is S8. We are seeing some selected partial sum. Which one is equal to 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 8, isn't it? Plus 1 over 8. This one is greater than this is greater than 1 plus 1 over 2 plus 1 over 4 plus 1 over 4 plus 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8. Since 1 over 5 is greater than this one, 1 over 6 is greater than this, 1 over 7 is greater than this. So S8 is greater than this term. That is equal to 1 plus 1 over 2 plus 1 over 2 plus this one is 1 over 2. That's equal to 1 plus 3 over 1 plus 3 over 2, 1 plus 3 over 2, 1 plus 3 over 2, and so on. S3 to the power of 4 in a like manner, and continuing S to the power of n is greater than 1 plus n over 2. N over 2. Look, limit of Sn as n goes to infinity is equal to the limit of to the power of n. Here, so limit of Sn as n goes to infinity is equal to the limit of S to the power of n as n goes to infinity. As n goes to infinity, that's equal to positive infinity. That's equal to positive infinity, which is the limit of 1 plus n over 2 as n goes to infinity is equal to positive infinity. Therefore, the sum of 1 over n from 1 to infinity is divergent. Divergent sequence is a divergent sequence is a divergent sequence is a divergent sequence 1 over 2 is a divergent sequence. Telescoping series. Telescoping series is a series of the form a1 minus a2 plus a2 minus a3 plus a3 minus a4 plus a4 minus a5 plus that series that have this property is called a telescoping series. A series that we seen so far, that is 1 over n into n plus 1 when n from 1 to infinity. That is equal to the sum of 1 over n minus 1 over n plus 1. N from 1 to infinity is an example of a telescoping series. Is an example of a telescoping series. Another one is the sum of say 1 over 4n square minus 1 when n starts from 1 to infinity. 1 to infinity is another example of a telescoping series. This series is convergent if and only if the limit of a1 minus an plus 1 is equal to a fixed real number. Is converges to this series converges to the limit of a1 minus an plus 1, a1 minus an plus 1 as n goes to infinity. Converges. This series converges if and only if this limit is exists as a number. Another type of series is P series. P series is a series of the form the sum of 1 over n is the power of p, n from 1 to infinity, and p is greater than 0. P is greater than 0 is a series of the form, the summation of 1 over n is the power of p when n starts from 1 to infinity is called a p series. When p is a number greater than 0 and is convergent, this series is convergent if p is greater than 1 and divergent if p is less than 1. If p is less than 1. The proof need integral test. The proof of this one need an integral test that we will see in the next topic. One another type of series is a geometric series. Geometric series is a series of the form, say a plus a times r plus a times r square plus a times r to the power of 3 plus that can be written as the sum n star from 0 to infinity a times r to the power of n r to the power of n. It is a series of the form system. It's called a geometric series. Here, geometric series. Here, a number is different from 0. Number a is different from 0. And r is called a common ratio of the series. Common ratio of the series. Common ratio of the series. So series of this form is called a geometric series. Take the sum n from 0 to infinity. Say 1 over 2 to the power of n is geometric series. Geometric series with a is equal to 1 and common ratio r is equal to 1 over 2. R is equal to 1 over 2. This series is convergent if absolute value of r is less than 1. That means minus 1 is less than r is less than 1 and divergent otherwise less than 1 and divergent if absolute value of r is greater than or equal to 1. If absolute value of r is greater than or equal to 1. Let me prove the convergence of the geometric series. We will prove this one by cases. Case 1. If r is equal to 1, the series becomes the sum n from 1 to infinity a times 1 to the power of n, that is 1. That is equal to a plus a plus a plus plus, which is divergent. Since Sn is equal to n times a, and the limit of Sn as n goes to infinity is equal to the limit of a times n, n times a as n goes to infinity, that equal to infinity. That is equal to infinity. And if r is equal to minus 1, the series becomes what? The series becomes the sum a times minus 1 the power of n from 1 to infinity. And it is partial sum. It is partial sum. Sn is equal to 0 if n is even and a if n is odd. If n is odd, which implies the limit of Sn as n goes to infinity doesn't exist. Does not exist. That implies the series converges. The series diverges. The series diverges. So the series diverges for r is equal to 1 minus 1. For r is equal to minus 1 and r is equal to 1. R is equal to 1. if r is different from plus or minus 1, Sn is equal to a plus a times r plus a times r square plus a times r is the power of n. If r is different from plus or minus 1, different plus or minus 1. This implies if Sn is equal to this one, then what will be r times Sn? R times Sn is equal to a times r plus a times r square plus a times r the power of 3 plus r is the power of n minus 1. Since n starts from 0, Sn is equal to a times r the power of n minus 1. This implies r times Sn will be ar square, ar cube plus a times r is the power of n. A times r is the power of n. This implies S minus r times Sn is equal to Sn minus r times Sn is equal to this minus this. That's equal to a minus a times r is the power of n. R is the power of n. This means 1 minus r times Sn. This is equal to a is common, a times 1 minus r is the power of n. This implies Sn is equal to a times 1 minus r is the power of n over 1 minus r. Now let us see the limit of Sn as n goes to infinity. The limit of Sn as n goes to infinity is equal to the limit of a times 1 minus r is the power of n over 1 minus r as n goes to infinity, which is equal to a over 1 minus r times the limit of 1 minus r is the power of n as n goes to infinity, This limit converge if and only if the limit of 1 minus r is the power of n is converges, if and only if this converges. So for the convergence of this limit, r must be a number between minus 1 and 1. R must be a number between minus 1 and 1. So this limit is equal to a over 1 minus r times 1 times 1 minus 0. 1 minus 0. 1 minus 0. That's equal to a over 1 minus r. Since the limit of 1 minus r is the power of n is equal to 0 and converges, equal to 0 and converges if and only if absolute value of r is less than 1. Absolute value of r is less than 1. Absolute value of r is, if absolute value of r is less than 1, this limit is equal to 0. This one is 1 and diverges if r is equal to 0. Diverges r is equal to 0. Therefore, the sum of a times r to the power of n when n starts from 0 to infinity is equal to a over 1 minus r if absolute value of r is less than 1 and absolute value of r less than 1, and diverges is equal to this one if absolute value of r is equal to 1, and diverges if absolute value of r is greater than 1, greater than or equal to 1. Let me give you some examples of infinite series. Determine the convergence. Determine the convergence of the sum of n from 0 to infinity 4 over 5 the power of n. The sum n from say 1 to infinity 4 times 5 the power of n minus 1 over 4 the power of n minus 1. So this series is what? Geometric series with r is equal to 4 over 5, that is less than 1, therefore the sum 4 over 5 the power of n when n is from 0 to infinity is equal to or converges to 1 over 1 minus 4 over 5. 1 minus 4 over 5. This series is a series of the form, the sum n from 1 to infinity a times r to the power of n, a times r to the power of n, or geometric with a is equal to 4 and r is equal to 5 over 4, that is greater than 1. Therefore this series 4 times 5 to the power of n minus 1 over 4 to the power of n minus 1 when n from 1 to infinity is divergent series. There are following number as a geometric series, and then express them as a rational number, a 0.33, B 5.25, 5.23, and continue. Now let us see this series. Now 0.33 can be written as 0.333 can be written as 0.3 plus 0.03 plus 0.003 plus. That is equal to 0.3 is 3 over 10 plus this one is 3 over 100 plus this one is 3 over 1000 plus. This one is equal to 3 over 10 into 1 plus what? 1 over 10, isn't it? 1 over 10 plus 1 over 100 plus 1 over 1000 plus. This is equal to 3 over 10 times the sum of 1 over 10 the power of n when n start from 0 to infinity. N from 0 to infinity. From 0 to infinity. That can be written as the sum n from 0 to infinity 3 over 10 times 1 over 10 the power of n. 1 over 10 the power of n, which is of the form the sum n from 0 to infinity a times r the power of n, where a is equal to 3 over 10 and r is equal to 1 over 10. Therefore, the series 3 over 10 times 1 over 10 the power of n when n starts from 0 to infinity converges to a is 3 over 10 over 1 minus r is 1 over 10. That's equal to 3 over 10 over this one is 9 over 10. That's equal to 1 over 6. Since r is less than 1. When we see the numbers given in B, 5 plus 2 3 is equal to 5 plus what? 5 points. 5 point. This one is equal to 5 plus 0.5 plus 0.23 plus 0.0023 plus 0.000023 plus. That is equal to 5 plus 0.23 is 23 over 100 plus this one is 23 over 100 square plus 23 over 100 the power of 3 plus. This is equal to 5 plus 23 over 100 times 1 plus 1 over 100 plus 1 over 100 square plus. Therefore, this is equal to 5 plus 23 over 100 times the sum n start from 0 to infinity 1 over 100 the power of n. That's equal to 5 plus the sum n start from 0 to infinity 23 over 100 times 1 over 100 the power of n, the power of 5 plus this one is 23 over 100 over 1 minus 1 over 100. 5 plus this one, that's equal to 23 over 100 minus 23 over 100 over 99 minus 99 over 100, isn't it? 99 over 100. That is equal to, yeah, there is 5 here. There is 5 plus 5. That's equal to 5 plus 23 over 99. Using the property of the geometric series is one way by which we can convert the repeating decimal into a rational number, number. Thank you very much. I will come with the next topic. So it is enough for today.